Okay, all of you are almost in. Okay, yesterday someone told me want to revisit space complexity, right?
Yes, ma'am.
Okay, wait, now share my screen. Can you guys see my screen?
No, ma'am.
No. Let's start again. Can you see now?
Ma'am.
Yes.
Yes, ma'am.
Okay. So yesterday we discussed about space complexity, right? So who had the doubt actually? What's your doubt? Yesterday who said someone has doubt? Now no one. See, space complexity, if it is in algorithmic form, suppose in this case, there is no mention about what type of variable. So general rule is you need to consider all of your variables and constants and any other temporary variables or return types. Okay. In this algorithm, you have three variables A, B, and C. So what is it doing? It basically just adding up two numbers, then adding an extra 10, then saving it to C. So since we have three variables, so each of these variable will take one unit of space. One unit of space taken by each constant and variable. So this 3 is for your variables. Then this one is for your 10. 10 is a constant. So it will take one unit of space as well. So in this case, your space complexity is just 1 plus 3 equal to 4. Now that was just algorithmic point of view, right? Because here I haven't mentioned what are the types of variables. Here I am only mentioning or telling you the rule that you need to consider all variables and constant, and if there is any other statement or temporary variable, you need to consider that one too. Beta, I got a call. Okay, sorry. So if you need to calculate space complexity, you need to calculate one unit for each variable, constant, and the return types or any other temporary variables. So here the algorithm has three variables. So each will take 1 unit of space, then constant will take another unit. So total. So next, in this case, we have two statements. We have four variables, right? Now here I'm mentioning that variables are int type. Then also returning the variable which is also int type. Now I provided this table where you need to remember what is the amount of memory or size of the memory taken by each of the data types. Like for int, it takes 4 bytes. Okay, so for 4 bytes, we have 4 variables. So 4 into 4, how much? 16. Then we have another return type. It's also int type. So it will take another 4. Therefore, total will be 20 bytes. Is it clear to you all?
Yes, ma'am.
Who had doubt yesterday? Who was talking about doubt?
Ma'am,
Okay.
but I again missed the thing that I missed yesterday.
What's that thing?
Ma'am, ma'am, the previous slide and maybe the slide before that.
This one, this one, this one.
Yes, ma'am, this one.
The
This one, ma'am.
table one, is it?
Hmm.
So what's the doubt here?
Ma'am, we need to calculate for every variable. For the second example, I couldn't understand how we got the plus 12.
Plus 12, which where?
Ma'am, no, for the second
Ah,
example.
second one. Okay, this
This
one.
one.
Okay.
Yes, ma'am.
Okay. What happens here? It's again,
Plus,
okay. Is it 12 or 16? Where did you see the 12?
ma'am, 4 and plus 16.
4 and plus 16. Okay. See
Hmm.
what happens in here? We have how many variables? For the
X
time being,
and
just
X.
think about n, I, x, right?
Yes,
And
ma'am.
we have one array A. So your array is of n type. Sorry,
Hmm.
int type. So it will take 4 bytes. Now I have not mentioned the size of your array. So if I tell you your size of the array is 10, then total amount or total memory size taken by your int array will be 4 into 10, 40. Okay.
Hmm.
So since I
Yes,
have
ma'am.
mentioned only n, so right now it's just 4n bytes of space required by array A. Okay, you got it how it is 4 because in type 4 and n will depend on your size of the array. So next, how many variables we have? 3. X, n, I apart from your array.
Hmm.
So each of these variable will again take 4 bytes. Correct?
Yes, ma'am.
So this 4n is for your array. Then for
Hmm.
these three variable, it will have 4 bytes, right? Now again we have a return type,
Yes, value.
correct? So your return value is x. So x is again int type, correct? So it will take another 4 bytes. So
Hmm.
including
So,
your three variables plus return, each of them will take 4 bytes and therefore 4 into 4 is 16.
hmm.
Okay, so your total memory requirement will be 4n plus 16. Now, if your array size is 10, then 40 plus 16 equal to 56. Right?
Yes, ma'am.
Is it clear now?
Yes, ma'am.
Okay. Okay, next we discuss about asymptotic notations. What are these? They are basically just your some boundaries. Like asymptotic means it's like your algorithm or function is approaching a value or is like a curve arbitrarily closely. Means it just approaching some limiting value. Can you guys remember the limiting maths we used to do in class in school? You guys remember those limit related math?
Yes, ma'am.
So
The what related?
limit in high school we had maths, right? Limit 1 to 0 or 1
Yes,
to
ma'am.
infinity. So this is also something similar to that. Means it provides the boundary to your algorithm. So when we say like it mainly calculates what running time of an algorithm. So we just mention it mathematically that your algorithm or program should not go beyond this limit of time, this amount of time. So execution time should be like 5 seconds or 5 minutes. It should not go beyond that. So for that we have three notations: big O. Big O is mostly for worst case, and this is the means main running time of the algorithm, because most of the time we only care about what will be the maximum time taken by a program or an algorithm. So for all the programs and algorithms we mainly calculate worst case. So apart from big O, so big O is your upper bound. So whatever your function or your time requirement or complexity, it will just go, it should not always go beyond this boundary, upper boundary. Now, yesterday I already mentioned these are all big, you can say capital letters, okay? Big O notations or big omega or big theta, like that. Then there's another small o, small theta, small omega. The difference is only that here they are just giving upper bound. Okay, so if your algorithm goes beyond these boundaries, still it's like okay, sometimes it might go beyond, but it's not tightly bound. Now, when in case of like a small o, it will give tight bound. Okay, means your algorithm should not go beyond this point at all. It's like strictly bound. Now, for big O, if I'm telling you that your algorithm should not pass through beyond 5 minutes, then your algorithm might take 5.1 or 5.2 minutes, right? So that one is still acceptable sometimes, but if you use small o, it will tell you that it should not go beyond 5 minutes at all. So anyhow, your algorithm should finish before that particular time. Okay. So about small notations, we'll get to know in that the subject design and analysis of algorithm in next semester. During this semester, we will only concentrate about these three notations: big O for worst case, omega for the best case, the theta for average case. So worst case provides you upper bound, omega provides you lower bound, and the function will always stay above your limiting boundary. Then theta will be used for average case. So always remember these expressions. Okay, it's like everywhere you go in next semester also they'll ask you these formulas. Okay. Now, why time complexity is important? Because there can be like n number of solutions for different algorithms. So here as well we have two algorithms. So which one will be efficient? Number two is efficient. Why? If you see this example one, you can see we have three numbers and it's using loop. So for n number of input size, it, it will keep running on. So if you have lots of input, it will keep adding up numbers one by one at a time. So it will take lots of time. And in algo 2, it is just one step. So it's a constant time. This is kind of statement, just one liner. It will just take constant time, right? This multiplication will be just one unit of time. So it's a constant. But from in this loop, it's mainly depending on your input size. So it is kind of linear function. Okay. Now how we can calculate time complexity? Can you all see the screen?
Ma'am.
Okay.
Yes.
So what we need to do, we need to count the number of elementary steps performed by any algorithm to finish execution. And in any algorithm, it will take 1 unit of time for arithmetic and logical operation. So whatever arithmetic and logical operation you will have in your program or algorithm, it will take 1 unit of time. Then another unit of time will be taken by assignment operation and return types. Okay. So big O notation, what it does, it removes all the constant factor so that running time can be estimated in relation to n. So in both space complexity and time complexity, it mainly depends on input size. I'm just repeating the same thing over and over again. So not only big O, any other notations will simply ignore all those parts. Those are not giving any contribution to the running time. Okay, so it will just discard all the constant factors and will keep the actual value that will dependent on n. For example, in this simple function, sum a of b, what's the time taken is 2. How 2? Because here one addition operation is done, a plus b. This is a arithmetic operation. So for this operation, it's taking 1 unit of time. Then again I mentioned here another 1 unit will be taken by return statement. So return will also take 1 unit of time. So total will be 2 units. And since it's 2, it's like a constant time. Is it clear to you guys? In this portion, any doubt? Dipashri,
No,
any doubt in this portion?
no, no, no.
Okay, others? CR, why are you so quiet this time? सिमिलर है क्या? क्या तुम लोग ऐसे ही फोन लगा के चले जाते हो क्या?
Ma'am, our network both them.
नेटवर्क गया.
I think it's connectivity problem. Yes, ma'am.
ओके.
Network again.
अच्छा. बाकी Arunasa, Tanmoy, Ritupal, Dulab, Yogesh, everyone can understand, right?
Yes,
Yes,
ma'am.
ma'am.
This portion. Okay, so moving on to next. So here I'm just mentioning assignment or arithmetic operation will take 1 unit and return type will take 1 unit. So
One
total
minute.
2 units. So now let's check the other one. This is the same algorithm we use to calculate the space complexity, right? So what will be the time here? So I already mentioned each of your functions starting from arithmetic operations, then comparing, increment, assignment, any kind of operation, it will take 1 unit of time, return will take 1 unit of time. So how we can calculate, suppose I am just giving some numbers to each of these instructions. So first line is, I'm just noting it as 1, second line 2, then this is third line, and this is fourth line. So there are total 4 lines in this function. Okay. So it's a bit complicated to calculate time complexity. So just see carefully. In line number 1, what's happening? It just assigning
Finding.
the value, or you can also say initializing the value of x. So for this particular statement, it will take just 1 unit of time. Okay. Then for second line, what's happening? It's a for loop. So within the for loop, 3 operations are happening. Correct? One is initialization, one is like it comparing, then other one is incrementation. So for all these 3 operations, for means running this for loop, it's taking 3 costs. Your cost will be 3 for all 3 operations. Okay. So your time will be n plus 1. Why n plus 1? This one is also for calculating the false of the statement. See, this for loop, what is it doing? It just comparing the values and checking whether it is going beyond n or less than n or not. So as long as I less than n, it will keep adding the numbers in array. Correct? So the moment this condition will fail, the loop will stop running and it will exit from the loop. Right? So for this exiting condition, or the condition when this will be like the ending condition, it will take another unit of time. So time for this for loop is n plus 1. Cost is 3 because we have 3 operation inside your for loop. So cost is 3. Then what time it's taking? It's mainly depending on the number of input size, right? If your array size is 10, the loop will run for 10 times, correct? So n is for that. Then one extra time is when for exiting the loop. So n plus 1. Got it? Is it clear to you guys how it's n plus 1 and how cost is 3? Say yes or
Even
no.
for
It's very important.
exiting the loop, we have another 1 plus. Why
Yes.
so?
This extra, see, this loop will run for n times for n number of input. Now it will also check the false condition as well, right? The moment it reaches the false condition, it will get out of the loop. So this extra 1 unit of time is for exiting the loop or for the false condition. Okay. So for the third statement, what's happening? One is just doing arithmetic operation, adding the values to array, then it also assigning the value to the x again. So two operations are happening. So your cost is 2. Okay. Then again, this loop or this statement will run for n number of times. So time is n. Okay. Then for return statement, it's just constant time. So it will run just one time. The cost is 1 and running time is also 1. So after calculating this, what we need to do? We need to calculate the total time. So what will be the total time? It's 1 plus you need to multiply this cost into time. Okay. So for the first line, your total time is 1 into 1 equal to 1. Okay. For the second line, the cost into time will be 3 n plus 1. Okay. For third line, cost into time equal to twice n. And for the last line, fourth line, is also cost into time equal to 1. So if you now add up this line, it will come as 5n plus 5. Now here 5 is a constant, then here 5 is constant again. So we can represent it as C1 n plus C2, right? Now remember I already told we only care about that particular term that is directly related to your input. So which one is the important part is the 5n, because this particular expression or term is going with your input side. So it will simply discard the 5 portion or this C2 term. We'll consider only 5n term. Uh, Then we can also convert it as C into n. C is your constant term and n will remain same. So time complexity will be only n. Again, the constant part will be neglected. So see, I'm repeating again because it's a bit complicated. So in this
Ma'am,
part, yeah,
line 10, ma'am.
line which number?
line line number 2, ma'am.
Line number 2. Okay, I'm repeating everything again. Okay. So in line number 1, what's happening is just assigning a value. Okay. So for this particular statement, it will run just one time, right? So since only one operation, the cost is 1. And since it's going to run just one time, it's not depending on the input size of the array, right? So time will be 1. So for the second one, line number 2, which is a for loop. So inside the for loop, we have 3 operations. So I already mentioned for any arithmetic or logical operations, logical means comparing and all, it will take one unit of time. Okay. So for loop, we have 3 operations. So the cost is 3. Now suppose in this case, if I remove this initialization part, suppose your for loop consists of only this initialization and comparing part. The increment part, I put it inside your body part. Then your cost will be 2. Is it clear to you guys how the cost can be changed? It will depend on the operations inside your loop. Since in this particular loop, I am writing it like initialization less than this and it's I plus plus, the total 3 operations are happening. So your cost is 3. Wait, I'm just showing. If I just remove this part, suppose there is no I plus plus, then how many operations here? Suppose I'm just writing I plus plus with some other values. Maybe means implementation part, how it should implement. I'm just writing it in a different way. Suppose I don't want to implement in a sequential way like 111. I want to implement it I plus 2. Okay, and I want to add it later in the body. Okay, so in this case, the cost for loop will be 2. Is it clear to you guys now? How cost can be changed inside the for loop?
Yes, ma'am.
Okay, I'm just keeping it like previous one. There will be I plus plus 3 operations, so total 3. So since 3 operation, cost is 3. Then the time part. See, your for loop will run for n times, right? Every time it's comparing whether your I is less than n or not. So since it will run for n times, the time is n. Okay. Now this one extra is for the exiting condition. See, your for loop will not run forever, right? There is a condition at which your for loop will come out, right? There will be a false condition too. So for that false condition means when your I will be, see when you write an array, you just keep checking the locations, right? 0, 1, 2, 3, 4. So the moment it reached the end, then it will again compare with the last element again. So when the position is going beyond this limit, means when I is greater than equal to n or greater than n, that is your false condition. So this one will be added. Now again you remember that even I am putting this as n plus 1, anyway you can remove this one part. Why? Because I already mentioned ultimately we are going to ignore all the constant part, right? So but initially you have to mention that it's 3n plus 1. 1 is for your false condition when your for loop will come out. So the total time is 3 plus 1. Now for the third statement, what's happening? It's one addition operation. So one addition operation, then assigning to x again. So there are total two operations happening: addition and assignment. So cost for this line number 3 is 2. And how many times this statement will run? It is for the n times. Here n plus 1 won't come because the moment the first condition will satisfy, this statement will not be executed. So this statement is true only for the condition when I less than equal to n. So this statement will run for n times. So your timing is n. Then fourth is return x. This is a single liner statement. So cost is 1 and time is also 1. So in the end, you need to multiply the cost into time. Okay. So for the first line, your cost into time is 1. 1 into 1. Then in this term, your cost is means total time is 3 into n plus 1. Then for the fourth line it's twice n, and for the fourth line it's 1. Third line is twice n. So if you add up all these numbers, it will be 5n plus 5. So again, we are going to ignore the constant term because we are only care about the term which is directly related to your input size. So this 5n term is mainly important because here we can see it's depending on the input size. So if n equal to 10, then it will be 10, 50 and all. So when we calculate the time complexity, we are again going to ignore this constant term. So finally, it will be only n. Okay. Even if I ask you to calculate like omega on or theta on, then again it will be same case. We are going to ignore all those constant part or all those terms which are not that important. So only that part we are going to consider where input size is directly related to it. So here linearly it will increase the time. So if your n is 10, it will be 50. If your n is 50, then it will be 100. Sorry, 50. Then again, if it's n equal to 100, it will be 500 and so on. So your time is increasing linearly with your input size. So this is the linear time complexity and it's On. See, this expression we can also expressed as C1 and C2. C1 is constant for 5 and 5 is a constant too. So I'm just defining it C1 and C2. So from C1 and C2 again we can ignore this C2 part and finally it remains just C1n. So I can just express this term as Cn. Okay. So your time complexity is On. Is it clear to you guys?
Ma'am,
Is this clear?
Yes, ma'am.
Paisha?
Ujishu.
Ma'am.
Dipashri? Is it clear?
Yes, ma'am.
Okay. Everyone is clear. Then we have certain general rules. I want to show, see, now calculating in this way is going to take lots of time for you guys, right? if your program is too big, if you start like doing calculating all the operations and all the statements, it's going to take a long time for you guys to calculate the time means immediately, right? So there are certain general rules. With the help of those rules, you can calculate time complexity of any program very easily and very quickly. So should I start this now or next class? Do we have time? When is the next class?
Thursday.
No. Now next class is when? 11.
Thursday.
11:15 biology.
I stop sharing for a while. कौन नहीं है आज? 20 participants including me. Wait, check. So should I go for the general rules today or next class? Next class. Okay. So you guys have a bit means info, right? How you can calculate time complexity. Like you need to calculate cost and time. When there are almost like 5 general rules, if I show you that means how you can calculate very easily, it will be very easy for you guys to calculate it. You no need to think about this like number of operations in a statement and all. Anyways, I started late. Okay, just try for a while till the moment meeting gets ended itself. Okay, is it okay? Is it okay for you guys?
Yes, ma'am.
Ma'am. Yes.
Okay, okay, I'm going to share the screen again. Okay, can you see the screen? Can you see
Yes,
the
ma'am.
screen?
Yes, ma'am.
Okay. For showing the general rule, I want to know from you means whether you are getting it or not. Okay. So any guess what will be the time complexity for this one for this particular
1 minute.
statement? 1 minute. Very good. Others? So here I am showing you three three functions or three equations. So the time complexity for number one will be 1 unit, or you can say constant time. This statement is going to take just constant time. It can be 1, 2, depending on the statement. Okay. So anyway, it will be just constant time. Then in the next one, what will be the complexity? It's almost similar to this one. So this should be here. Everyone, what will be the time complexity for these two?
Thrice n plus 4.
N plus
3 n plus 4.
3 plus. Okay, if you boil down to the big O notation, then what will be the big O
Uh,
notation?
big O, big O n
Big O,
or 3n.
big ON is the correct one. Okay. So in this one statement for one, what will be the big O notation for this?
Constant.
Constant. So
um,
whenever you have constant, then your big O notation will be 1. So time complexity for this expression will be O1. Okay. Then for this one, any guesses? For two loops, everyone try and tell me. I want answer from everyone. What will be the total time? Yeah, first just tell me what will be the total time.
6n plus 7.
The others, others also try first, then I'll tell you. Any guesses? Okay, it is double for loop. There is a one for loop within another for loop. So if this for loop is a number one, then this two statement is under another for loop. So just think about it. Anyways, I'll explain next class, but you guys first try, okay? Any other answers?
Ma'am, is there a possibility of a square?
Yes.
Then 3n square plus 4n plus 1.
Others? What's your answer again?
Ma'am, 3n square plus 4n plus 1.
Okay, if your answer is 3n square plus 4n plus 1, whatever you are saying, then what will be the big O notation for this?
And we go n square.
2n square plus n.
Okay, someone said n square and conversion, no?
Oh, ma'am.
Correct? Deepa, you are saying
Ma'am, big O n square plus n.
n square plus n. Okay. Others, anyone else want to say? বাকী ঋতুপল, দুৰ্লভ, দীপু আৰু তোমালোকৰ বহুত কেইটা আছা? আছানে চব বাচি? শুনি আছা? বাচি আছা? কিবা বুজি পোৱা নাই যদি সুধিবা। सबको समझ में आ रहा है? Anyone wants to answer? Okay. কোৱা কোৱা। Just try it. I'm going to explain it next class. Going to give very simple way how you can calculate. Okay, you have class. Okay. Okay, so Tonmoy's answer is correct. It's ON square. Dipasri, your answer is also kind of correct. But the thing is, I'll explain next class, okay? Why it's not n square plus n and why it's only n square. Okay? Okay. Others try as well. Next class, I'll just show the general rules. It will be easier for you guys to calculate the complexity. Then no need to calculate the cost and about the constant term at all. Okay? Okay, see you in the next class. We have next class now.
Thank you, ma'am.
You can just leave the class. Okay, anyway, it's ending. Thank you, everyone.